A deuteron and an alpha particles are accelerated with the same potential. Which one of the two has one greater value of de Broglie wavelength associated with it and two less kinetic energy? Explain. Lambda equals h upon p. Here, the lambda is the de Broglie wavelength of the particle. P is the momentum of the particle. Let us write momentum as m times v. So, let us write the velocity in terms of kinetic energy. So, half mv square equals k. From here we find what is v equals root of 2k upon m. Lambda equals h upon m times, in the place of v we have written root of 2 times k upon m. Simplifying this, that means the m goes into the square root, become m square and cancel with a m in the denominator. Therefore, the lambda equals h upon square root of 2mk. So, let us rewrite this equation. Lambda equals h upon square root of 2mk. Here, the k is the kinetic energy of the particle. Kinetic energy equals Q times V. This is the electrical energy. Q is the charge of the particle. V is the accelerating potential. So, lambda can be written as h upon root of 2m Q times V. We are going to use this formula. The de Broglie wavelength of the particle lambda is proportional to 1 upon square root of m Q. From here we start the neat problem. Before, what we learned is just an introduction. So for this particular problem, lambda proportional to 1 upon square root of mq. Now, mass of the deuteron is 2 times mass of the proton. Then, mass of the alpha particle is 4 times mass of the proton. Charge of the deuteron is E. Charge of the alpha particle is 2 times E. So, lambda d upon lambda alpha equals square root of mass of the alpha multiply charge of the alpha divided by square root of mass of the deuteron multiply charge of the deuteron. So, lambda d upon lambda alpha equals the mass of the alpha is replaced by 4 times mass of the proton and charge of the alpha is written as 2 times E. Mass of the deuteron is 2 times mass of the proton, charge of the deuteron is E. The MP cancel and E cancel, we get lambda d upon lambda alpha equals 8 upon square root of 8 upon square root of 2. It becomes a square root of 4, so we get 2 upon 1. Lambda d equals 2 times lambda alpha. Therefore, the wavelength of deuteron is greater than the wavelength of alpha particle. So, lambda d is greater than lambda alpha. The wavelength of deuteron is greater than the wavelength of alpha particle. So, we know that the kinetic energy is Q times V, where V is the accelerating potential, K is the kinetic energy of the particle. The kinetic energy of the particle K proportional to charge Q. Therefore, Qd is E, Q alpha is 2 times E. Therefore, the kinetic energy of deuteron upon kinetic energy of the alpha particle equals E upon 2E. We get the kinetic energy of deuteron equals kinetic energy of alpha particle upon 2. So, half a time of kinetic energy of alpha particle. Therefore, the kinetic energy of alpha particle is greater and the kinetic energy of the deuteron is lesser. So, we get Kd is less than K alpha.